right, so this is solving systems of linear equations by substitution. So you always want to remember the solution to a system of linear equations is going to be the point of intersection. So if the lines are parallel, there will be no solution because two parallel lines will not intersect. All right, so let's start with this problem, the first problem in your packet. So 5x plus 3y equals 7. That is a linear equation in standard form. You should recognize that as a linear equation, even though it's not in the form y equals mx plus b. It's in the form ax plus by equals c, where they're all integers. Remember, standard form, everything has to be an integer. In this equation, y equals 4 is going to be a horizontal line, and y will always be 4. So we just need to figure out what x is. Substitution. Take the y guy and stick it into the first equation. All right, so you know y equals 4. So you're going to put it into the first equation. You solve for x. When you put 4 in, this equation here, once 4 goes in for y, you have one variable, one equation. You can solve and you get x equals -1. You'll go back in and check and make sure that works, and the solution to the system is -1, 4. That's where those two lines will intersect. All right, so go ahead and try this one. Try it yourself. Turn off the video. Remember, you have a numerical value for x, so wherever you see x in the first equation, you're going to put in 3. All right, so hopefully you've taken care of that. Now, x equals 3, remember, is a vertical line. X will always be 3. So the point of intersection you have there is 3, -2. If you need to see work, I'll have it worked out in class. Well, here's another one. All right, and the first equation, once again, is written in standard form. This next equation is just linear because x and y are raised to the first power, but it's not written in any form, so-called form. All right, so but since x is already solved for, we can take that 2y minus 3, and in the first equation, wherever I see a x value, I can put in the value 2y minus 3. So there you go. You solve for y. Once again, this has one equation, one variable, so we can get a numerical value there. And it's y equals 5. But we're not done. We only know the y value. Now we have to find the corresponding x value. So we have x equals 2y minus 3. We now know that y is 5. When we put 5 in for y, we get x equals 7. So our point of intersection is 7, 5. Make sure that it works in both equations, that the point 7, 5 makes both of the original equations true. So you go ahead and do this one and come back, or actually just check with me. If you're not sure where to start, well, we have a y equals something x. So I would take that, whatever y is, put it in parentheses, and replace it with the y value up in the first equation. Okay, now these are both written in standard form. Here's the clue though. If they're both written in standard form, you want to find the variable the variable that has a coefficient of 1 or -1. If you're going to use substitution, you only want to use substitution if one of the variables in either equation has a coefficient of 1. Right? So here's a key to making your life happier. You don't want fractions. So if possible, you want to pick a guy to solve for that doesn't create fractions. Right? So which one up here? So think about it. Which equation would you solve for? Or what variable would you solve for and which equation would you use? Alrighty, so because this y value here, y variable has a coefficient of 1, that's what I'm going to solve for because it's going to make my life so much easier. So you substitute, solve for x, you get x equals 3. Go back in to that y equation. Wherever you see an x, you'll put in a 3. You'll get y equals 5. So your point of intersection will be 3, 5. And make sure it works in both equations. Okay. Now, same problem, but what if we decided we were going to take the bottom equation and solve for x? Yikes, yikes, yikes. Look at all that stuff. We get very, very ugly numbers, right? Fractions. So please don't make me go on. That thing got really brutal fast. So if you can, always solve for, this says for a guy with no coefficient in front, but you want a coefficient of 1 or -1. And here he says x, -x, y, or -y. So if you get to this type of a problem, we shouldn't use substitution. There's a third way we're going to solve systems tomorrow called elimination. So if I get something this brutal, we're not going to use substitution. All right. First way we had to solve systems was graphing. Today, substitution. Tomorrow, called elimination or linear combination. So go ahead and solve this equation, and then come check your answer. And I will be passing out a homework sheet for you. If you have questions, please come see me.